For over 5 decades, the Moon has waited in silence. Since 1972, no human has dared to venture beyond low Earth orbit, until now. Artemis II is not just a mission. It is humanity's first step back into the deep dark. 4 astronauts are about to ride the most powerful rocket ever built, aiming for a destination that has haunted our dreams for half a century. To understand the magnitude of Artemis II, we must look beyond the simple idea of a lunar trip. This is not a direct shot to the Moon like the Apollo missions of the past. It is a carefully choreographed 10-day flight test designed to push the Orion spacecraft and its 4-person crew to the absolute limit. The mission profile is broken down into distinct critical phases, each presenting its own set of lethal challenges. It all begins at Launch Pad 39B at the Kennedy Space Center in Florida. The Space Launch System, or SLS, will roar to life, generating a staggering 8.8 million pounds of thrust. This makes it the most powerful rocket ever to launch humans into space, surpassing the legendary Saturn V. Within minutes, the solid rocket boosters will separate, and the core stage will push the Orion capsule into low Earth orbit. But unlike previous missions, the crew does not head for the Moon immediately. For the first 24 hours, the astronauts will remain close to home. They will perform 2 orbits around the Earth. The first orbit is elliptical, keeping them relatively close to the surface to ensure all life support systems are functioning correctly. This is a critical checkout phase. If anything goes wrong here, they can abort and return to Earth quickly. Once the systems are green, the upper stage of the rocket, known as the Interim Cryogenic Propulsion Stage, or ICPS, fires again. This maneuver raises their orbit into a highly elliptical path, taking them nearly 40,000 miles away from Earth. Here, the crew will perform a unique proximity operations demonstration. They will manually pilot the Orion spacecraft, separating from the spent rocket stage and then turning back to face it. This is a test of Orion's handling capabilities, simulating the docking procedures that will be required for future moon landings. Once this delicate dance is complete, the crew prepares for the most significant moment of the early mission, the trans-lunar injection. The main engine fires, accelerating the spacecraft to over 24,000 miles per hour. This burn breaks the bonds of Earth's gravity and sets them on a trajectory toward the Moon. This is the point of no return. For the next 4 days, the crew will coast through the vacuum of deep space, traversing the 230,000 miles between our planet and its satellite. The trajectory NASA has chosen is known as a hybrid free return trajectory. This is a stroke of orbital mechanics genius. The spacecraft will not enter a low lunar orbit. Instead, it will use the Moon's massive gravitational pull to sling itself around the far side. The geometry of this path resembles a giant figure 8. The beauty of this trajectory lies in its safety. If the main engine fails after the translunar injection, the Moon's gravity will naturally curve the spacecraft's path and fling it back toward Earth without requiring a major engine burn. It is a gravity-assisted failsafe. As they pass behind the Moon, the crew will lose communication with Earth for approximately 45 minutes. They will fly roughly 4,600 miles above the lunar surface. While they won't be close enough to touch the regolith, the view will be unparalleled. They will see the cratered, rugged terrain of the lunar far side, a face of the Moon never visible from Earth. And as they emerge from the shadow of the Moon, they will witness the iconic Earthrise, seeing our entire blue marble suspended in the black void. During this flyby, Artemis II will set a new record. The crew will travel further into space than any human beings in history, venturing thousands of miles beyond the Moon, breaking the altitude record set by the crew of Apollo 13 in 1970. They will truly be in deep space, exposed to higher levels of radiation and isolation than any astronaut on the International Space Station has ever experienced. The return journey is just as perilous. After the lunar flyby, gravity accelerates the Orion capsule back toward Earth. The trip home takes about 4 days, culminating in the most violent phase of the mission, re-entry. The spacecraft will hit the Earth's atmosphere at a blistering speed of Mach 32. That is nearly 25,000 miles per hour. At this speed, the friction with the atmosphere creates an envelope of plasma around the capsule, generating temperatures reaching 5,000 degrees Fahrenheit. This is half the temperature of the surface of the Sun. The heat shield must hold. To manage this energy, Orion will execute a skip entry maneuver. Imagine skipping a stone across a calm lake. The capsule will dip into the atmosphere, bounce back up to cool off, and then dive back in for the final descent. This technique allows for a precise landing and reduces the G-forces on the astronauts. Finally, if the parachutes deploy correctly, the capsule will splash down in the Pacific Ocean, marking the end of a journey that covers over 1.4 million miles. This mission profile is not just a loop, it is a declaration of capability. It proves that humanity is ready to leave the cradle of low Earth orbit once again. A mission of this magnitude requires more than just advanced engineering and orbital mechanics. It requires a crew capable of handling the unknown. For the first time in history, the humans venturing to the Moon look more like the humanity they represent. The 4 astronauts selected for Artemis II are not just passengers. They are some of the most experienced and capable individuals on the planet, each bringing a specific set of skills vital for survival in deep space. Leading the mission is Commander Reed Wiseman. A decorated naval aviator and test pilot, Wiseman is no stranger to the vacuum of space. He previously spent 165 days aboard the International Space Station in 2014. Before being assigned to Artemis II, he served as the chief of the astronaut office, a role that required him to oversee the safety and assignments of all other astronauts. He stepped down from that prestigious leadership position for one reason: to return to the flight deck. As commander, Wiseman is the ultimate decision-maker. In the event of a communication blackout or a critical system failure, the lives of the crew rest in his hands. His leadership style is known for being calm under pressure, a trait that is essential when you are thousands of miles from the nearest help. Sitting in the pilot's seat is Victor Glover. Glover is a powerhouse of experience. He was the pilot for the SpaceX Crew 1 mission, the first operational commercial flight to the space station. On Artemis II, his role changes significantly. While modern spacecraft are heavily automated, Artemis II requires manual piloting demonstrations. Glover will physically take control of the Orion capsule to maneuver it during the proximity operations in Earth orbit. This requires nerves of steel and incredible precision. Historically, his presence marks a monumental shift. Victor Glover will become the first person of color to travel around the Moon, shattering a barrier that has existed since the dawn of the space age. Joining them is mission specialist Christina Koch. If there is anyone who understands the long-term effects of spaceflight, it is her. Koch holds the record for the longest single spaceflight by a woman, having spent 328 consecutive days in orbit. She also participated in the first all-female spacewalk. Her background is in electrical engineering and physics, making her the technical expert on board. On a test flight like Artemis II, where sensors, life support and power systems are being pushed to their limits, having an engineer of her caliber is critical for troubleshooting. She'll become the first woman to leave low Earth orbit, redefining what is possible for future generations of women in STEM. Rounding out the crew is mission specialist Jeremy Hansen. He represents a vital change in the philosophy of exploration. Hansen is a Canadian Space Agency astronaut, making Artemis II the first international mission to the Moon. For the first time, a non-American will venture into deep space. A fighter pilot with a background in space science, Hansen has been waiting for a flight assignment for over a decade, training relentlessly in cave explorations and underwater habitats to simulate alien environments. His presence signifies that the return to the Moon is not a race between nations, but a collaborative effort. Canada's contribution of robotics, like the famous Canadarm, has earned them a seat at the table, and Hansen is the embodiment of that partnership. Together, these four individuals have spent years training for this specific 10-day window. They have practiced splashdowns in the open ocean, run countless simulations of catastrophic failures, and studied every inch of the Orion capsule. They are not just going to the Moon to look out the window, they are going there to work. They are paving the road for the Artemis generation. The vehicle making this journey possible consists of two engineering marvels, the Space Launch System rocket and the Orion spacecraft. Standing at 322 feet tall, the SLS is an absolute beast. It is powered by four RS-25 engines, veterans of the Space Shuttle era, and two massive solid rocket boosters. Together they produce enough raw energy to push 27 metric tons to the Moon. It is the only rocket in existence capable of sending Orion, the crew and their supplies to deep space in a single launch. Once the roar of the engines fades, the crew's reality shrinks down to the Orion capsule. For 10 days, this will be their entire world. The habitable volume is roughly 9 cubic meters. To put that in perspective, imagine 4 people living inside 2 mid-sized minivans for over a week. It is intimate, to say the least. But every inch is packed with next-generation technology. The most critical system being tested on Artemis II is the ECLSS, the Environmental Control and Life Support System. On the uncrewed Artemis I mission, this system was just dead weight. Now it has to work. It must scrub carbon dioxide from the air, maintain a comfortable temperature, and manage humidity while the crew generates heat and moisture. They will also be testing a new radiation vest called the AstroRad. Since they are travelling through the Van Allen radiation belts, protecting the human body from high-energy particles is a top priority. Orion is not just a vehicle, it is a lifeboat in the middle of a cosmic ocean. Artemis II is the final exam. If this crew succeeds, the door opens for Artemis III. That is the mission that will return humans to the lunar surface. But we're not going back to the same places Apollo visited. We are heading to the lunar South Pole, a region of permanent shadow, extreme cold, and most importantly, water ice. But even the Moon is just a proving ground. The systems being tested on this flight, the life support, the navigation, the radiation shielding, are all pieces of a much larger puzzle. The ultimate destination is Mars. A mission to the Red Planet will not take days, it will take years. We cannot leap straight to Mars without mastering deep space survival first. Artemis is how we learn to walk before we run. We are living through a pivotal moment in history. For 50 years, space exploration was limited to low Earth orbit. Now the boundaries are being pushed back. The rocket is built. The crew is ready. The trajectory is locked. Humanity is returning to the stars, and this time we are going to stay. Make sure you are subscribed to follow every update as we count down to launch. The era of Artemis has begun.